Hello, everybody. Welcome to OpenCV Weekly Webinar. And today I have with me Jeff Powers, who is the founder of a very well-known company you must know, Occipital. And right now he is leading an AR/VR company. And the name of it is, it's a bit tricky. I will let you, Jeff, pronounce it. But before that, I also want to mention that Phil Nelson is also with us. He's the content manager at OpenCV. And as always, he will lead the, he organizes the webinar for us. And welcome, Phil.
Hey, folks. As a reminder, we'll be doing Q&A like usual. Please use the Zoom Q&A functionality to ask your question at any point during the webinar, and we'll answer as many as we can at the end. There will also be a trivia question for a giveaway of a free license for OpenCV courses. Yeah.
So welcome, Jeff. I would like you to introduce yourself. You have several companies under your belt already. And also, you know, if you could explain the name of your current company. Yeah,
absolutely. So my current company is Arcturus Industries. And there's kind of a long history of why it's called Arcturus. It has to do with a secret project naming scheme that we had at Occipital years ago. But also it's kind of our thought is Arcturus is actually one of the brightest stars in the night sky. It's one of the closest stars. And the idea is that our computer vision tech is the best in the Milky Way galaxy, whether or not you're orbiting the sun or Arcturus.
That's great. That's great. So yeah, I mean, the talk is divided into two parts, right? One is all the AR/VR stuff you're doing at Arcturus, and I thought that it was related to AR/VR, but it is not. Okay, and in the first part we will go over stories from your first company, Red Laser, where you built an app for iPhone. A barcode scanning app for iPhone, and all the very interesting stories from that venture. And then we will come to Arcturus and figure out, you know, what you're doing in the AR/VR space, view synthesis, etc.
And so, eagle-eyed viewers may remember Red Laser from Vikas Reddy's webinar episode.
Great. So should I go ahead and get started?
Yes. Yes, please.
All right. Here we go. So. Yeah, it's great to be here. This is fun. This is like one of the longest talks that I've given in a while, so it kind of had to dust off my speech skills. Bear with me if they're not any good anymore. But at Arcturus, we're working on 3D perception for AR/VR. Arcturus does start with AR, even though it's not exactly before AR, but we do work on AR/VR, and our initials are AI, and we kind of do use AI too. So that's a little bit about Arcturus, but I'm excited to tell you guys some stories from 2009, 2010 about Red Laser, which was kind of the precursor to all the stuff we did at Occipital. But we will be talking about the tech we're doing at Arcturus, which is SLAM, view synthesis, and controller tracking. Before that, though, a little bit about the team. My team now is a 15-person team. I kind of like smaller teams these days, and my dream team size is like 15 to 20, you know, well-knit team, which all has like a Vulcan mind meld, and you can solve really big problems together. I kind of find that the perfect size. We're based in the US and Spain, actually. One of our lead engineers was actually from living in Madrid, and we decided this is an amazing city, relatively untapped from a computer vision perspective. Let's make that our home base. And so we actually have a team in Spain, and then some people in the US, and a couple of people dotted around. One cool thing about our company is we're actually really closely partnered with Valve. So if you've ever heard of, you know, Valve, you've probably heard of Valve, probably heard of Steam, you've probably heard of Half-Life, Portal. You know, they just announced something called Steam Deck. So this is a company that I've known and followed since I was a kid, and it's really exciting to be able to work with them on the intersection of computer vision and VR. So that's a little bit about us, but we'll get back to that. But for now, I'll start out with some stories of red laser, and feel free to interrupt me with questions, Phil or Satya, as we go. But red laser was founded in 2009. It was not our first idea. It was kind of our fallback idea after we failed to get interest in things closer to augmented reality back then. Just not a lot of investors were interested in that, or people just didn't think that people were going to be carrying their phones around and doing this kind of stuff all the time. Of course, in retrospect, they did, but we fell back to something a little bit more simple, which was barcode recognition on the iPhone. And the iPhone at the time didn't have an autofocus camera. So if you tried to take a picture of a barcode, it was incredibly blurry. You couldn't even read it as a human. So, the question was, could we actually get our phone to do it? In the end, we did. Kind of at the pinnacle, we were even featured in this Apple TV ad. I'll show you a few seconds of it.
And then I did a quick check to see if it was cheaper anywhere else. Turned out the best price was around the corner. I'm a much smarter and faster shopper with my iPhone.
The local result that you saw there may or may not have been something that we added to the database to make the Apple TV ad look better.
It still technically came from the app,
Did come from the app.
It's not cheating if you're not lying, Jeff.
So a few stories. First is we built red laser in a basement. Actually, we built red laser and its precursors in a series of basements in Boulder. So really, we got to Boulder to join the Techstars program. We were in a basement office with Techstars. We moved into a basement of a deli, a former deli, and then we moved into the office you can see me in here, which was in the Cartwright building, it's called, but it was a pretty lame office. We shared it with another company, another Techstars company, and that's where we basically built red laser. But what's funny is that office was actually nice compared to where we had been before. When Vikas and I were very first starting out working on ideas, we were in New York City. We had these two terrible offices, especially the Columbia office near Columbia University. It was a 6th floor walk up. And we actually at one point brought a huge server up our 6th floor walk up, which was a horrible mistake, because when we turned the server on, if you've ever used like big desktop servers, at least they historically had huge fans. And so this thing was sounded like an air conditioning unit. Needless to say, we basically never used that server. And I'm sure now that server would be probably less powerful than an iPhone. Another thing about red laser is it didn't work the way most people thought it worked. So whenever we talked to people, and lots of times we didn't correct people when they talked to us, but they would say, "Oh man, you guys have figured out how to deconvolve the image," and then you were then just running a regular barcode scanner on it.
Yeah, how are you doing all that on the phone?
Yeah. We were just like, yeah, aren't we cool? And
Right.
What we actually did though was arguably simpler, arguably more sophisticated, which was really, we were just doing an accelerated blur and compare, kind of, sort of simplify it. What we did is we took these images in real time. I'll tell you how we got the images in the first place, because the Apple didn't have a camera API for video. Mm-hmm. But we took these images and we figured out where we thought the barcode was. And then and I'll show you that. The way we did that was we took an image, and we took, even though these were blurry, if the region of the image that you're looking at contains a barcode, it's likely to be very similar vertically. So as you traverse up and down the image vertically, you'll see the same thing. And so we had a simple filter that basically did that. These days, you just train a neural net to do it, and the neural net would figure that out. But we didn't have neural nets really at the time, they weren't popular. So we were basically, we have this manual filter of looking if the image was similar vertically. If it was, we would have a higher score. If it wasn't, we'd have a lower score. Found the region that had the highest score. That's our barcode. But then what is the barcode? And what we would do is we would chunk that region into segments where we thought each digit would be. And then we would iterate through possible digits. We would optimize for lighting. So if the image was really bright, we would have sort of an offset and scale for that. If it was dark, we would have a different offset and scale. And then whether the barcode was tilted in plane, so it was tilted towards you or away from you, sort of on the left and right side. And so we had these parameters that we could iterate, and we basically just had this big simulate, compare, iterate, simulate, compare, iterate, simulate, compare, iterate. And that's how it worked. And in the end, whatever the optimal fit was, it would synthetically recreate this barcode. Whatever the optimal synthetic result was that most closely matched the real was what we thought the barcode was.
Right. And this was all before, deep learning was there, computational power was limited, et cetera, right? I mean, you could not do this on the phone back then. So it's quite interesting, right? The way you solved it. Why didn't you do deconvolution? I mean, there were papers around at that time for blind deconvolution. I was just curious.
We tried a little bit. I won't say we were experts in it, and I'm sure what's out there today would totally solve this problem. But especially if you had like a trained deconvolution that was using, barcode data as its input. Yeah. But we tried, and it just basically made these things sharper, but it made a lot of errors. You couldn't run, at least on the things we could find without doing a lot of our own research, you could not run a traditional barcode decoder on the outputs. It just wouldn't work.
Got it.
And also, if I recall, some of them are pretty slow. So what we did is actually faster than that approach.
Oh yeah, deconvolution is slow. And some of these things, there are these ideas, like I like to say that for every difficult problem, there is a simple, easy to understand wrong solution, right? So unless you have actually tried it, you don't know the complexity of the problem. You would think that some other solution is the obvious one, but that's not always the case. You have to get your hands dirty into some of these problems to understand the complexity, to understand the nuances of the problem, right? So while deconvolution looks like an obvious thing to do, in your case, you might have just found it simpler to do the way you did it, right? Instead of struggling with these deconvolution algorithms.
Yeah, it might have taken us years to make deconvolution work. Right. We got it in months. So, I showed you the barcode detector. Another story about red laser is that I still remember talking to Vikas about it, and up until maybe 1 or 2 days before launch, we actually were going to make the app completely free. And the idea was we were going to generate leads for our SDK, and that's where we were going to make money. And at the last minute, we said, why don't let's charge for it? Like, it's easier to make it free later. We charge for it now. And maybe we'll get better signal from our users whether or not they're interested in this app, and whether or not it's working for them. If they're actually paying for it, they're going to give us better feedback. So we did that, and it ended up in the end that we made 10 times more, more or less 10 times more on just selling the app than we did on the SDK.
Vikas Reddy, who's your co-founder, he was on this webinar also, as you know.
Yeah.
And he had mentioned that, he didn't mention the exact numbers, but somewhere at its peak, you guys were making $30,000 to $40,000 a day selling this app, right?
Yeah. Yeah, I have a slide that I actually do show you a little brief snippet of sales per day. But I think that's in 2 slides. But yeah, it was not that way initially. Initially, it was a flop, but we did eventually get up to many tens of thousands per day, and had pretty strong staying power on the App Store, staying near the top for a long time. So for a large part of the end of 2019 and 2020, we were, I think, in the top 5 or so of the App Store.
Did you mean 2009 and 2010?
Sorry, yeah, I did.
Right. Okay.
Yeah, 2009. Yeah, so long ago now. Yeah, 2009 and 2010.
Yeah,
it's been a long decade for sure.
But so the first version was a flop, and I'll show you this video, and you'll be able to tell why, I think.
Today we're going to show you Red Laser, the first accurate barcode scanning application for the iPhone. We're in Target right now, so let's scan a product.
So you take a photo, you have to take it from pretty far back so that we get the images as in focus as we could.
Yeah.
Zoom in, we use this slow Apple camera API to take photos, crop the image out, upload it to our servers.
Over an edge connection.
Over an edge. Oh, it says 3G there. And then and then it would send back the results. So you saw how long that took. The app generated hundreds of downloads per day, which we actually didn't think was terrible, but that was really all it got to. At some point, I actually came home for a visit, showed it to my grandma, and she just could not use it. Like I was trying to give her these instructions, just the idea of holding the phone back here while the barcode was up there, juggling, she could not use it. And I think a lot of users face that same issue, plus just the delay in time. It just wasn't successful. So we ended up being inspired by another app, which was this app called Sudoku Grab, and you can't get it anymore, but it was really cool. It was ahead of its time. The app would actually, somehow it was doing video processing. We didn't really know how at first, but we realized what they were doing is actually screenshotting the screen. So they would bring up the camera feed as if you were going to take a picture, but then instead of taking a picture, they would screenshot repeatedly and process the screenshot data, and that gave them a video feed. And but if you see here, there's actually stuff rendered on top of the video feed. How did they do that? What they actually did was, if you look at this zoomed in inset, they would render only at like a pattern of alternating pixels. So they could still sample in between where they were rendering to more or less figure out what the video feed was behind their rendering. And this was all done by a guy, Chris Greening, and it was just a really innovative app. And we saw that and we thought, this is it, we can do video processing. And that led to Red Laser 2.0, which was a big jump forward and did video processing in this way using this API. And so you can see here, this was running that algorithm I told you guys about earlier, where it was basically doing this sort of guess and check on the potential barcodes. And then the only thing you had to send to the server was just the barcode string itself. And so it was immediate to get the data up. We also did some smart stuff, like we'd stream you back the name of the product just in text, and you'd see that immediately. And then you'd stream back more data as we got price information. So people remarked about just how fast Red Laser was.
Yeah, that first, like the UX difference is, like night and day. But I noticed it does that smart thing where right away it shows you some information, right? Also, I noticed you can get closer to the barcode on this one.
Yes, you can get way closer, and that was critical because people just did not understand. And we got so many images where people did that basically with the original app, where they would just be right up against the barcode, and it's just not intuitive to people to stand back to take photos.
It's pretty interesting to me to be able to see the this same basic flow really repeated structurally through Structure Sensor and even Vikas's new startup Light Twist, where the idea is you do as much as you can right on the phone to get that visceral reaction right away, and then send it off to the server for extra processing if you need to. It's pretty cool to see that through line from this app all the way to today.
Yeah, that's true. Yeah, people like that instant gratification and that it's working. I think that's critical if you want to do computer vision at very large scales to everyday people. It has to be instant. So interestingly, we worked around an Apple API to do this. We were using this, we sort of were working around it, we sort of weren't. We were using this screen grab feature, and Apple would sometimes approve the app and other times not. Other times the reviewers would look at this and say, wait, I don't think we have like a video processing API. This isn't, you guys must be using an undocumented API. And then we would email app review and say, oh no, we're not. We're using this public API. And so we ended up spending 6 months of 2009 not consecutively, but in chunks where we were blocked from being approved on the App Store. And it was very stressful, but we just assumed, we were just like, well, this is the future. People are moving this direction. There's going to be video processing. Let's keep cranking. So we kept working on the app, even though we were systematically blocked. Finally, Apple did unblock us. I think it was around the time that we had achieved literally almost 10% penetration onto all iPhones.
Wow.
So Apple kind of had to pay attention.
Right. Well, not only did they pay attention, they made it part of your part of their ad, right?
Yeah. They leaned a lot into this. I mean, not just because of us, but we were one of the apps they paid attention to. They made sure they weren't breaking. They actually did contact us for feedback on the API that became AV Foundation, which does real-time video capture. And but we did have a tough time, and Vikas was actually asked to write a guest article in Newsweek, which he did in December 2009, where we had a few choice words about Apple's restrictive policies, and Apple wasn't very happy about that. So we worked around Apple's API. Is that all? No, we worked around Amazon's API too.
Did Apple do anything about it though? I mean, they were not happy in the sense that they sent you an email saying that please don't do this again.
They were not happy that we wrote that article.
Right.
So they asked us to maybe say some clarifying words because they had since improved the situation around the camera APIs. Right. So we wrote a comment on the post saying, well, it's getting better.
Right.
But no, I mean, they had just blocked us for 6 months of 2009. That's what they had done before. But then by this time, we were finally in the clear for doing video processing.
Right.
But we also faced another issue, which was we really wanted to show Amazon results. And we had found in Amazon's, we didn't actually sign up for their APIs for price search, but we actually saw in their APIs that it was restricted. You were not allowed to use the APIs on mobile apps, which to us was just this weird, arbitrary, strange restriction. And it didn't even seem real. It didn't even seem right. It was like, why not? Mobile apps is probably where you're going to get a lot of, commerce. So why restrict that? But the word on the street was that this came from Jeff, the Jeff that flew to space 2 days ago. And so we were just like, okay. So what we did is we had your individual iPhone. When you used Red Laser, your iPhone would actually do a search on Amazon, just like you were searching Amazon. Just like you go to the search bar on Amazon, you type something in. We would do that same query. We would get back whatever Amazon sent back, and we would send that as HTML to our server, and our server would then parse that. And our server just had a parser that we wrote that was, updated to handle whatever the latest version of the Amazon website was. And so it worked. And we were thinking, look, Amazon's probably not even going to know that we're doing this, that we're nobody, we're just this little app. They're not going to care. They're not going to know. And if they did, then they can't, what are they going to do about it, right? People's phones are just searching at Amazon for results. We're not actually using the API. So that's what we thought. A little more on that later. So then, I showed you the real-time version of the app, which was a huge step forward. But the interesting thing is it still wasn't an overnight success. It still was, one of the big issues with it was it wasn't fully supporting EAN barcodes. And the other issue, which is sort of the international UPC barcodes. And then it also wasn't, it was throwing off a lot of false positives. So you could scan something and maybe 20% of the time, depending on how you were scanning it, you'd get back no results because we decoded the barcode wrong. So what we did was we actually implemented a crude machine learning approach where we learned ratios for every digit. Some of the digits look similar to other digits. So a 3 in barcode form may look very, very different than a 7, but it may look kind of similar to a 6. And so for each digit, there was essentially scores of how likely it was that it would look similar to other digits. And we'd have these ratios of the best to the second best match for a given digit. And then we would accept or reject that particular decoding based on how close it was to its neighbor, to its second best digit. So if there was a 3, but we thought maybe it was a 5, if the ratio is really close, we would reject it. We would say we can't accept this barcode. But if the ratio was stronger and the 3 was really popping out as the best fit, we would accept it. And so we basically had that, and we tuned it using data. And that update, where we basically reduced the false positive rate, was the trick to making the app go viral.
Wow.
Which is crazy. It's like, we couldn't get press for that update. We got some press for our 2.0 update because it was a big new real-time update. 2.2, we got no press because it's like 2.2, who cares? What's better about it? Oh, it's a little bit better. Like, you can't get anybody interested in writing that story. But nevertheless, people started trying it and they said, wow, this is working. And then they would tell their friends and they would tell their friends and they would tell their friends. And it just had like an R score or whatever it is that was big enough that it just went viral. And so we went from essentially obscurity to the top of the App Store. Here it says in 10 days.
Wow.
Yeah.
That's amazing. Yeah.
Yeah. So the lesson there is, especially in computer vision and probably in other fields, like people often conclude that maybe your product, maybe the market wasn't ready for it, or maybe you didn't have the right marketing chops, or it's often true that you're not doing something right at a business level, but sometimes you're just not doing something right at a technical level. Sometimes it's just not working well enough. Does it work really, really well? And if it does, you may have a hit, even if you don't necessarily do everything else right, even if you don't have the best, PR strategy and things like that. And we certainly didn't. Like, we had no PR for 2.2.
So at this time, how many people were working with the company? It was just you and Vikas Reddy, or there were more people?
It was just the two of us because we didn't have any revenue to pay anybody. We actually almost ran out of money. We got a $12,000 loan from my mom to stay alive. We were paying ourselves something like $1,200 a month, which we eventually leveled up to $2,500 a month. It was just us. We couldn't afford anything else.
Right. That's great. So this update, within a few days, like 10 days, you shot to the top, like #1 on App Store.
Yeah, we were basically, whether it was 10 or 12 or 15 days or whatever, but we eventually made it to #1.
Wow. That's amazing.
Yeah. And, it's really hard to do that now because just of how much competition there is. But there are other places where you still have this opportunity to be, where it's a relatively small, relatively captive audience, places like the VR ecosystem now with the Quest. I mean, there's a lot now. It's probably more than first year or two of the iPhone, but it's still relatively early, and you can have a chance as a small team to be pretty big.
Yeah, I like to say that there are these platform plays that come once in a few years, maybe 5 years or so, where some platform is taking off, and if you catch it in the right moment, you just ride the wave. And in my previous companies, we were just known to not catch any of them. So, I was the founder of the company, so I have to take a lot of
extremely relatable, Satya. Extremely relatable.
Yeah, we missed the Facebook app boom. We did not catch that one. We missed the iPhone app boom. We were there. We were looking from the sideline, working on the new version of the website, right? While these things happen. Yep. And that's when I decided that I'm never going to let that happen again. If there is a big, wave I see, I'm going to leave everything. I'm going to catch that wave. I'm also getting all my, friends and family into it. Like this AI wave, for example, right now. I got my brother to, resign from his job.
Oh, wow.
Very well cushy job. I've been trying to get him to work with me for the last 2 years. And finally, he joined this year, right? So it's like all in now.
That's awesome.
Yeah.
Yeah, that's no. I think that's really smart, and now is the time. That's for sure.
Yeah.
Another funny story is, we did make it to the top of, if I recall correctly, we made it to top paid pretty quickly, but there's this other category called top grossing, which was actually making the most number of dollars. And if I recall, we had a lot of struggles with an app called I Am T-Pain, which was just hilarious. We're just like, oh, T-Pain's got us again. Like,
seems like a different world, doesn't it?
Yeah. So T-Pain was always there. And finally, we made it to top grossing.
Oh, sweet.
And displaced T-Pain at some point. But it was funny because even after that happened, we were sort of heading the utilities category. You can see our logo there, but there's T-Pain still causing trouble in the music category.
Right.
So we had these interesting struggles with Apple, but we also had a really interesting time with Amazon. So, I mentioned that Amazon had this policy supposedly from Jeff Bezos himself that they didn't want people hitting the API for mobile apps. And so we at some point had struck up a conversation with Amazon. We kind of stayed off the radar for a while. Eventually we struck up a conversation. We thought, Red Laser's succeeding. Let's try to get licensing deals with interesting companies. Let's try to do that SDK play that we were doing, that we thought was our ultimate future. So we had gotten in touch with Amazon. We were talking to them about licensing Red Laser. So the idea was they could license Red Laser barcode scanner in their own apps. So we flew out to Seattle to meet with them, and they were, excited to talk with us about licensing, but all of a sudden they bring in this guy who is basically like, hey, I forget if he was actually from legal or something. He's sort of like, I'm representing, basically our legal team, and you can't use the Amazon API in the Red Laser app. And we were just like, whoa, like we're out here to talk about licensing, and now you're like, stop using our API. So what did we say? We said, we're not using your API.
Au contraire, mon frère.
So they're like, we're going to shut you down. And we're like, well, good luck. You're going to have to shut down all iPhones from querying Amazon. And then they were sort of like, okay, well, then we're going to have to stop you in another way. And so that was very interesting. So definitely a rocky start talking to Amazon. In the end, though, it was kind of hilarious because eBay got interested in the company. We kind of went back to Amazon and said, are you guys interested? And their corp dev team got involved, and they were actually interested in acquiring us. And so they sent out one of their guys to basically do a diligence trip with us. And it just so happened that the day he arrived was St. Patrick's Day. And a really funny thing about the history of the Red Laser Occipital team is St. Patrick's Day was a holiday for us. It's a company holiday. Mm-hmm. And so we were like, well, St. Patrick's Day, talking to the corp dev guy, we're like, why don't you meet us at the bar at 7 a.m., right when you get in? And so this is actually literally a photo on the left of Connor O'Neill's, which a bar is unfortunately now closed, but he actually met us there. And one of the first things we did is have him do like an Irish car bomb, and we had a number of drinks, and he probably thought we were crazy, but I think we got him a little bit drunk because I still remember like later in the day when we're doing our diligence stuff, we were talking about, Mechanical Turk, and at some point he was like, oh, do you guys get like really inappropriate images uploaded to your Mechanical Turk stuff? And he's like, that happens to us all the time at Amazon. Like, in fact, it got so frequent that we called it the beep of the day. I won't tell you exactly what that was, but you can guess.
Yes.
And so this German guy's like, oh, the beep of the day, the beep of the day. So we're like, okay. Now
we are ready to discuss the contracting terms or licensing terms.
Yeah, let's immediately switch into that. Ultimately, though, we went with eBay, and it was fun, and it was interesting. Like a couple little stories from that. We had just gotten into we've been in contact with Apple about doing the Apple TV ad, and we really wanted eBay to close the deal. And so we were concerned. I mean, it takes a while to close these deals. There were questions about, I have a whole other stories about like IP, and their legal team was like, oh, this might be infringing on some patents. And it was this whole thing. And so we were trying to keep them interested. And I have this screenshot on the right of iTunes with Red Laser in the corner there. And we were doing everything we could to keep eBay excited. I think they would have closed the deal anyway, but we didn't know. And so we're out there visiting them, and we're like presenting different things on our computer screen. And I still remember, like, I would have iTunes accidentally up on my screen where I was showing Red Laser like at the top of the App Store. Just as a little subconscious hint that they should close the deal. Finally, they did close the deal, and we had a pretty hefty, like we were a little bit crazy. We were basically like, we can't go work at eBay. We have to do our next thing, which was panorama capture, which ended up being pretty successful too. And then ultimately other things like structure sensor. But we were like, they're like, but we need support. And we're like, okay, pay us a lot for support, and we'll come out and support you guys. Right. And so they flew us out for a support trip, and we got all prepared for the support trip. And in the end, more than providing support, we were essentially professional athletes for a day, because first we spent about an hour or two with discussions, and then they took us out to play bocce ball on the clock for a few hours. So we were paid literally at the level that some A-list professional athletes get paid per hour. If we'd been able to continue.
Probably way more than a professional bocce ball player gets paid.
Oh, far more. Yeah, we're talking more NBA level. We're talking $400 or $500 or $600 an hour. I forget.
That's really nice.
And but I still remember, like, they had dropped this app on one of their iPhone engineers, and I still remember he was like, "So this was your first iPhone app, huh?" Like, after he looked at the code, and he was just like,
but notice really, the transition. $500 is what you paid yourself a month, a year or two back.
Yeah, and then now we're getting paid that per hour.
Yeah.
But the eBay guys were awesome, and one of our regrets, I think, looking back, and of course you never know, hindsight's 2020, but looking back, I think we should have joined eBay, because we would have made out better financially. It was definitely a factor. We could have put that towards what was next. It probably would have been fun to work with them. And actually, we learned later on that, I'll tell you another story, but we learned later on that Tony Zhu, who actually went on to found DoorDash, was actually dropped in to basically lead business development for Red Laser. So too bad. Maybe we would have had some sweet early angel investment shares in DoorDash, which recently IPO'd, if we had actually gone to work at eBay. So a lesson that I have there is, for an early founder, if you have an acquisition opportunity, and if it's bigger, if you actually join the company versus just sell the product, which usually everybody wants you to join. If you're early in your career, take it. Don't, let your ego go a little bit. You're not going to be able to change the world in a year or two. I mean, maybe you can, but most of the time you're going to be better off going to the big company, working there for a few years, see how it goes, and then do your next thing. And then one last little bonus story. After the deal had closed, but before we had announced it, one of our competitors had somehow gotten wind of the fact that we, were closing this deal. And he didn't reach out to us himself, but we actually got an outreach from a venture capitalist who had expressed interest in Red Laser. And, he seemed somewhat legit. We looked at his portfolio, though, and we saw that he was an investor in our competitor. And so we were a little bit surprised by that, but that he was asking, that he was interested in us. And so he got us on the phone, and he basically started asking us, like, hey, word on the street is that you guys might be getting acquired. Is that true? And so I told him, I was like, I don't know what you're talking about. So I basically lied to him. And I was like, I think he's like trying to feed this information back to our competitor. And I wasn't sure though. Right. But then about a month later, after the deal had closed, our competitor actually straight up emailed us, and he was like, hey, so how much was the deal? What did it close for? I'm trying to close a similar deal. I need to know comparables here. And we didn't tell him. We were just like, really? We're not going to tell you. And then he was like, never lie to VCs. They have very long memories.
Talk about, in the pantheon of passive aggressive threats.
That's awesome.
Yeah. And there's so many other stories that we don't have time for. Around Martha Stewart, we used Mechanical Turk in some super interesting ways. It was a crazy ride considering it was only about, a year and change. So.
That's great.
Yeah. So, pausing there for anything on red laser. Otherwise, I want to talk about what Arcturus is up to.
Yeah, let's hear about the new stuff.
Cool. So at Arcturus, we are basically working on a new generation of spatial perception for VR and AR devices. Pretty much that's going to be headsets. It could also be maybe things you carry around that are spatially aware. But these things need SLAM, which I assume a lot of the OpenCV audience will know about SLAM, simultaneous localization and mapping, figuring out where you are just from looking out from a camera. We need controller tracking because you need input. It's not just about where you are, it's also about where your controllers or maybe hands are. We've chosen to focus on controller tracking at first. And then we also do some stuff in view synthesis, and I'll talk about that. But so jumping right in with view synthesis first, if you've used a VR headset like the Oculus Quest or the Valve Index or HP Reverb, you'll know that the cameras on the headset are not where your eyes are. But if you wanted to do perfect video pass-through, you literally want cameras exactly where your eyes are, right? You can't do that because you can't put cameras in your eyes. And further, on a lot of the headsets, they choose to separate the cameras even wider than the human interpupillary distance. And so the cameras might be 100 millimeters apart and your eyes are 65. And this causes things to feel wrong. It'll cause you to trip over things if that pass-through is just rendered straight to your eyes. If there's VR content rendered on top of, if you fuse together the real world and the VR content you're seeing, and you fuse them without correcting for that, it won't move correctly. So it's very disorienting. And so that's what our view synthesis tech sets out to solve.
It's also funny, the very first algorithm that I implemented as a grad student for my own, I just wanted to try out things, was a view synthesis paper by Steven Sides. And I just wanted to do it for the fun of it, right? I just wanted to see whether this thing actually works or not. So it brings back very good memories.
My phone, so I'm going to ignore that. So to go into this a little bit, on the left, if you look at this chair, it's a little bit distorted, and that's kind of like, this is a video, actually, this is a quick click from Oculus on their view synthesis technology, which they call Pass-Through Plus. And I'll just play a few seconds here of this clip. But they compute a mesh, and they use that mesh to essentially correct the appearance of the room as viewed from your left and right eyes. And we do the same thing with our technology, which has now been launched last year with the Valve Index as Room View 3D. So a little bit for the tech audience, how does this work? So at first we have these stereo inputs. We don't have LiDAR data. We don't have active depth. We don't have time of flight. We just have stereo cameras. So the first thing we do is we do stereo block matching, basically identical to OpenCV stereo block matching. In fact, I think we may even be calling it OpenCV stereo block matching currently. But then we do something pretty interesting, is we actually run a bilateral filter on that, and I'll talk a little bit about that, but that allows us to basically densify the depth in a smart way. We turn that into a mesh, we actually do a time warp. One of the cooler things is because we have this ephemeral model, this mesh of the world in front of you, if we know how you're moving into the future or ahead of the last camera frame that we had, we can actually change your viewpoint, make you, synthetically have you render a view from a slightly different position than where your last camera frame was from. And we make heavy use of that because the pipeline of getting camera frames captured into a VR rendering system, rendering them, getting them to your retinas is pretty long. It can be 60 to 100 milliseconds. That's a long latency. But with the IMU, we can extrapolate your motion with maybe 2 millisecond latency.
Wow.
And we can, and there's still a rendering latency of maybe call it 20 milliseconds or something, but we can basically predict where your eyes are going to be exactly when this rendered content goes on screen. And we can time warp you into the future. So we're literally time warping the cameras into the future, projecting the camera feed from from a certain number of milliseconds ago onto that reprojected world, and then rendering it into your eyes. So for things in the scene that are actually that are static, it's not exactly perfect. It's close to perfect though. It's great.
And
for things that are dynamic, it's not as accurate.
This is happening, about 50 frames a second, or
yeah. So the stereo part is probably happening around 30 to 50 frames per second. The bilateral part is probably similar. The time warp is happening at 90 or 120 frames per second. So
the overall system is still real time, 30 frames a second.
The camera feed is on the valve index is 54 frames per second from the camera, but the ultimate rendered output, which is smoothed and every frame is different based on that time warp.
Yeah.
Is rendered at usually 90 to 120, or even up to 144 on the index hertz.
Interesting. Wow. Okay.
Yeah. And a little about the bilateral filter. There's a lot of details in how we make this fast, but the basic idea is, and you can use bilateral filters are very cool, and you can use them for a lot of different things for making, doing artistic images. You can do it for cleaning up, like essentially doing edge-aware image sharpening. But you have an input image, which is, it's an intensity or an RGB image. And the basic idea is we have some depth information that we get from traditional block matching, and we want to pair it up so that areas in the image that have a similar color will have a similar depth. And we'll have that depth propagate out until you hit an edge, essentially, and then stop propagating. And that allows us to basically fill in all the holes. For example, if we have a little bit of depth on the edge of a wall, but we don't have any depth on the wall itself, the wall color will be very similar, so we can propagate that depth onto the wall. It's not perfect, but it's pretty good, and it's very fast. And so that's basically what our system does. And so you can look here, this is an example from a paper showing using this ultra coarse depth input and using this image on the left, they're able to use bilateral filtering to upsample and enhance the depth to have a plausible and in general more accurate depth map. And we basically do that in our system as well.
So one of the things, Jeff, I want to emphasize here is that, with deep learning and everything, deep learning being the, dominant technique these days for a lot of problems, people forget that when you're building a product, you need a combination of these skills, right? You can't just know deep learning and be able to build a product. You need to know a lot of traditional computer vision techniques as well, so that they augment your skill, right? The curve that you had shown, the little details there, right? You make small changes which lead to big impact, happens only when you have this broad set of tools, not just a single hammer with which you hit everything.
Yeah, that's a great point. And even in deep learning, a lot of the innovation in 3D deep learning comes from integrating some traditional knowledge about geometry and appearance and all these different ray tracing and implicit surfaces and all these new things are inspired by geometric understanding and prior intuition. So to succeed, you need to do both. And also, yeah, for real products, you often can't run deep learning in production, at least for many tasks, you can't afford to, because you can't run it fast enough. And so you need to be clever. Maybe you can run it periodically, maybe you can run it on alternating frames, but often you can't run it on every frame. So right. You have to figure out clever tricks like this bilateral filtering. So a little quick video demo of our view synthesis. So on the left, you can see our SLAM running, and on the right, you can see the synthesized left-right views being sent to the user. And it's a little hard to tell, but the left and right camera views are not identical. And when you have the headset on, you feel that things are actually at the correct depth. Actually feels right to you. Whereas if we don't do this correction, everything just feels wrong. So yeah, that's our view synthesis, which is now shipped as RimView 3D. We haven't shipped any big updates to it in the last year, but stay tuned.
Yeah, people in the audience that have Index headsets can try that out in the options menu.
Yes, and I wonder if I had cut this video a little bit short, because there is a part that I thought's really cool. Let me replay it again. I think towards the end of this clip, we switched to like an edge detect mode where we render the edges instead of the camera view, and you can actually blend the VR and AR together, or VR and real world together. It's really cool. Wait for that. I could be wrong, and we don't actually do it in this video. I'm probably wrong. Okay, here we go. Cool, yeah, so check this out. So here we're actually fusing the two, and if you look carefully, you can see that basically everything's moving in unison. It really feels like the desk is glued inside of your VR scene, which is really cool.
Nice.
So the next topic that we work on for obvious reasons on a VR headset is tracking. And the problem here is that methods that use external tracking, like base stations, for example, have the problem of you have to set them up. They're more difficult to carry from place to place, so you can't just take your headset somewhere and show somebody. You have to really set up the environment. They're more costly, and just all these things together basically hinder adoption. And on top of that, if you don't have cameras or camera processing, you also can't do some smart things like understand the room and do automatic room setup. Again, here's a screenshot from Oculus showing this off on their Quest system. But SLAM tracking gives you lower cost. You don't have to have the base stations. The room setup can be almost instantaneous. It can detect the floor. It can figure out the obstacles. And you can also start to play with AR experiences inside of VR, which is a nice bridge to the future. So that's why SLAM tracking makes sense. How we do it at Arcturus is fairly unique. We combine together camera. It's a visual inertial system. We're combining camera data and IMU data at every frame, and we're even using IMU data in the future, even newer than the last frame. We fuse that all together. We reconstruct not only points, which people are somewhat familiar with. We also reconstruct lines in the scene. That'll help us reduce accuracy. It also helps us, or improve accuracy. It also helps us provide us with a better conceptual view of the obstacles around you. Lots of times, little point clouds are hard to correlate to the real world, but line reconstruction is much easier. And our system is really fast. It's tuned to have a front end part that's extremely quick, and then a back end part that's optimizing the entire map of the scene around you. So I'll just show a couple of clips of that. So here we are mapping the scene, where we're just kind of moving around, relatively gentle, and you can see as we move, the map gets built. So that's how the system maps. And now I'll show you a little bit more aggressive motion. So here we're playing with this virtual dog, and you can see our head rotations are pretty quick here. Playing fetch. We're also robust to you blinding the left and right camera. So it's a stereo slam system. So if you're blinding one camera, we can still track with the other camera. So here we're blinding one camera, but tracking is unaffected. And then just to push it here, you can see some really aggressive motions playing Space Pirate Trainer. Actually, no, playing whatever this game is inside the lab. You can see it's robust to pretty crazy motion. Even frames that are basically untrackable with the camera, we can still maintain track with IMU data.
Wow.
Yeah, if anybody has out there has tried this on the in Valve's the lab, you know that this is, they basically pushed the action as far as you can push it without just physically making people sick.
All right, so we are pretty close to the end of
yeah.
Yeah, go ahead. Actually,
sorry. Yeah. So should we can we go a couple minutes over, or should we basically wrap up now?
No. Let's go a couple of minutes over.
Okay.
I think we can. Okay. Do you have the question ready, Phil? I just want to make sure that people get their chance at the goodies, and then we will go a couple of minutes over.
Yeah, definitely. So
people who miss out can still watch the YouTube recording, right?
Totally makes sense. So I'll do the trivia question here, and then we can get back to the rest here. For people that are here for the first time, the way this works is that I'm going to ask a question based on the slides from Jeff's presentation. The first person to answer correctly in the Zoom chat here on my screen, whether you send it to me or the room or just presenters or whatever, it doesn't actually matter. Whoever answers first will win. Satya, would you like to tell them what they'll win?
Yeah, they will win our course, Deep Learning with PyTorch.
And as a reminder, the Indiegogo campaign for the new OpenCV courses ends on Friday. So head on over to Indiegogo and lock in the tremendous savings there. So the trivia question is, the former head of business development at Red Laser, Tony Zhu, went on to found what food delivery startup? All right, here come the answers. I see, looks like Priyesh Sharma is our first answer here. Congratulations, Priyesh. We will be in touch after the show to hook you up with your free Deep Learning with PyTorch courses.
That's great. So yeah, let's, thanks, Phil. Jeff, take us home, with the remaining slides.
I'll keep it quick. Sorry, we had so much content. I over-indexed.
Yeah, it's all good. It's been fun.
I still have time for questions if anybody else does at the end. Otherwise, really quickly, the last piece that we've been working on recently at Arcturus is controller tracking. You can actually follow us on Twitter if you want to see progress. We're actually posting a lot of this live as we go. But I won't motivate this too much, but basically you need input, and we need to be able to do it from the headset. So you don't need base stations. So our project has been purely virtual. We decided to actually simulate the controllers in a special way, not actually building physical controllers at first. This allows us to basically tweak the algorithms, tweak the hardware virtually as we go. It just allows us to iterate extremely fast. So we model the controllers in Blender. We actually chose to render them in SceneKit because we have familiarity with it. You could use another engine. In SceneKit, we're able to live render these controllers with whatever orientation, whatever position we want. And it's totally in real time, so we don't have any offline rendering required. We can, doing that though is somewhat robotic. You need a more natural motion. So we actually have the ability to record and replay a real trajectory. So here you can see we're recording controller motion and actually head motion from real controllers. We play back in this real-time interface. You can see just how much more natural it looks. Control the lighting in real time. We can make the controllers flash however we want. We just learned a lot about building these kind of systems in the past. We wanted to make this one fully real time. One of the cooler things that I haven't shown before today is what do you do when you want to simulate really wide field cameras? Here we're actually showing that we can simulate fisheye cameras, but as we go to a really wide FOV, we're using a traditional, pinhole rendering engine, and you see what happens. Like at 180 degrees, the pinhole projection breaks. You can't do it. And so basically you get these extremely blurred images, and that's just not usable. And so to fix that, we actually are rendering, instead of one view, we're actually rendering a triangular prism. We could also render a cube all around you, but we're rendering into a prism because we only need 4 views instead of 6. And so we automatically, here we can see we automatically switch from traditional single view pinhole to multi-view triangular prism rendering. And so this allows us to render, again, in real time, up to 180 degree field of view.
Wow, that's a big difference.
Wow.
Yeah. So a little bit about how our system works. We detect blobs, really just like OpenCV blob detection. But the problem is we don't know which blobs correspond to which LEDs on our virtual controller. And if you were to just randomly permute that and try to do that association, you come up with something like 20 million possible associations for blob to LED pairs, and that's just not solvable. So we make the assumption that blobs that you find that are close in 2D are probably also close in 3D, and we reject candidates that are not close in 3D. That gets us down to 20,000 associations, and with some really smart solving, we can actually do that in real time. And so that actually allows us to bootstrap our controller poses in real time, and you're seeing the raw output of the vision-only bootstrapping here. There's multiple solutions. We're only using 3 points for the solve, and there are these degenerate, right. So these reflections and things like that. One of these is correct though, and so where we're going from here is actually integrating IMU information, and we actually haven't shown this really yet either. I'll give you guys a little peek though. Here we're fusing simulated IMU data with the camera data that you just saw, and we're able to go from that flickery, bootstrapping to a fully tracked controller.
Right.
And way smoother and more accurate. And then the final peak is, we probably won't be showing this off for a few weeks, but we can even do it with multi-controller.
Oh, sweet.
Yeah. So yeah, that's the tech I wanted to show folks. Also, Arcturus is hiring if people are interested. But yeah.
That's great. So where can people reach you, the people who may be looking for a job?
They can reach me at jeff@arcturus.industries, or they can tweet at me at jrpowers.
That's great. So that's about it. Thank you so much, Jeff, for this amazing presentation. I really loved your stories, and I'm amazed by what you're doing at Arcturus Industries now. Amazing stuff, really amazing stuff. And thanks for being here.
Thanks, it was a lot of fun. I'm sad I went too slow to have time for questions. So if anybody does have follow-up questions, please don't hesitate to reach out.
We'll just have to have you back on again, I guess.
Just do a full hour of questions.
That's great.
I really appreciate the opportunity to join. Thank you, guys.
Thank you. And thanks, Phil.
Yeah, thanks, everybody. We'll see you again next Thursday, 9 a.m. sharp.
Okay, bye.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Visit opencv.org/courses to learn from the experts.